Hi Algebra 2, this is Unit 10, Lesson 10, and today we're talking about polynomial long division. So we're going to start off just by doing a regular long division problem, just to make sure that you remember how to do this. And basically what I do is 13 goes into 15 once. 1 times 13 is 13. I subtract, bring down the 7. 13 goes into 27 twice. 13 times 2 is 26. Subtract, bring down the 3, and 13 goes into 13 once. So that's my answer, 121. So when I'm working with polynomials, it's the same idea, and here are the steps. First, you divide the first term of the numerator by the first term of the denominator and put that in the answer. You multiply the denominator by that answer and put that below. Subtract to create the new polynomial. Bring down using the new polynomial to repeat the process. If a term is missing, it's important that you use 0 as the coefficient in it. So let's look at this first problem right here. So I have x cubed plus 5x squared plus 7x plus 3 divided by x plus 3. So basically x plus 3 is out here, and that's going into x cubed plus 5x squared plus 7x plus 3. So here's what I do. X goes into x cubed. I'm only looking at the first term. X squared times. Right? So I'm just looking at the x and the x cubed. Now multiply. X times x squared is x cubed. 3 times x squared is 3x squared. Now I'm subtracting that. I'm subtracting the whole thing though. So the x cubes cancel. 5x squared minus 3x squared is 2x squared. All right, and I bring down the 7x. Now x goes into 2x squared, 2x times. X times 2x is 2x squared. 3 times 2x is 6x. I subtract. These cancel. 7x minus 6x is x. Bring down the 3. And x goes into x one time. 1 times x is x, and 1 times 3 is 3. So when I subtract it, I'm left with nothing. All right? So basically, you're dividing the first term of the numerator by the first term of the denominator. Each time I did that, I was looking at x goes into x cubed, then x goes into x squared, 2x squared, then x goes into x. I'm just looking at those first terms. All right, let's try another one. Grab a different color here. So x plus 6 goes into 2x squared plus 15x plus 18. All right, so x goes into 2x squared, 2x times, because 2x times x is 2x squared. 6 times 2x is 12x. I'm subtracting that. So these cancel. 15x minus 12x is 3x. Bring down the 18. X goes into 3x 3 times. 3 times x is 3x. 3 times 6 is 18. And I subtract that. I'm left with 0. So my answer is 2x plus 3. That's what I get when I divide 2x squared plus 15x plus 18 divided by x plus 6. All right, I forgot to write my answer over here. My answer was x squared plus 2x plus 1. All right, let's look at the next page. So find the quotient using long division, just like I did. This is similar to the other ones, but this time I'm going to have a remainder. All right, so I'm going to take that x plus 6, and it's going to go into 2x squared plus 15x plus 20. So x goes into 2x squared, 2x times. X times 2x is 2x squared. 6 times 12x, 2x is 12x. I'm subtracting that. So these cancel. 15x minus 12x is 3x. Bring down the 20. I'm just looking at the first terms. X goes into 3x 3 times. 3 times x is 3x. 3 times 6 is 18. I subtract, and I'm subtracting the whole thing. The 3x is canceled. 20 minus 18 is 2. So basically my answer is 2x plus 3, and then my plus, the remainder, 2 over x plus 6. So the remainder of 2 is over the original denominator, 2 over x plus 6. All right, so when we divide two polynomials, we always get another polynomial in a remainder. This is known as writing the rational expression in quotient remainder form. So that's what I had, quotient remainder form. All right, so the form looks, here it is, quotient remainder form. So I'm going to have some number, some quotient, and plus the remainder. All right, let's try these two. So I have x minus 3, x squared plus 2x minus 5. So x goes into x squared, x times x is x squared, x times negative 3 is negative 3x. Subtract, 2x minus negative 3x is actually 5x. Bring down the negative 5. X goes into 5x 5 times. And I multiply 5 times x minus 3 is 5x minus 15. I cancel those 5s. Negative 5 minus negative 15 is actually 10. So my answer is x plus 5 plus the remainder over that original denominator of x minus 3. All right, hopefully you're getting the hang of it. X minus 10 goes into 2x squared minus 23x plus 17. So x goes into 2x squared, 2x times. 2x times x is 2x squared. 2x times negative 10 is negative 20x. I'm subtracting these. The 2x's cancel. Negative 23 minus negative 20 is actually plus 20, which gives me a negative 3x. Bring down the 17. X goes into negative 3x times negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 10 is positive 30. All right, but I'm subtracting that, so be careful. Negative 3 minus negative 3 cancels. 17 minus 30 is negative 13. So 2x minus 3 is the quotient plus the remainder of negative 13 over x minus 10. All right, one more page. This page is called synthetic division. You're either going to love this or hate it. Synthetic division is a shortcut to long division. Synthetic division can only work if the divisor, that's the thing that I'm dividing by, has to be in the form x minus a. Okay, so that's the only time it works. Now here's what you do. That a is going to, so it's x minus a. A is the number that I am putting out here. I list all the coefficients of the polynomial without skipping over any powers. So if there are any powers that are missing, I do have to put in that 0. All right? And basically, you are dropping the number, multiplying, and then adding. All right, I'm going to show you. So you just keep repeating that process. It's a little tricky. But anyway, let's look at an example, because I think it will make more sense if you see it with numbers. So basically, I'm dividing by x plus 3. But I have to do the opposite sign. So instead of that 3, the number that's right here is negative 3. So just to know where that came from. Now, where did all the other numbers come from? So the other numbers come from the coefficients. See these? Now, I have x squared, but I don't have an x. That's why I need a 0 placeholder in there, and then I have the 6. So all of those came from those coefficients in the numerator. So here's what I do. I drop this number down. The 4 comes down. Negative 3 times 4 is negative 12. That goes here. And then I combine these. Negative 5 and negative 12 is negative 17. Multiply. Negative 3 times negative 17 is positive 51. So it goes up there. 0 plus 51 is 51. Negative 3 times positive 51 is negative 153. That goes up there. Then I add them. Positive 6 plus negative 53 is negative 147. These numbers here become my answer, okay? So these, let me pick a different color here. These numbers here become the answer, the quotient. See how those numbers came here? And then this number here is the remainder. So basically, synthetic division is you're doing division without, technically, you're just using those coefficients in front. You're not using the x's at all. All right, and that's my answer. All right, so let's try these. I had to rewrite these because for some reason they were a little messed up. So I'm going to take the 2. All right, so just to keep it the same color as before, I had yellow, so let me match that. I'm going to take this, all right, and I'm going to write that right there. So that's going to be positive 2. Now I'm going to take all these numbers. I had them in green, all right. These numbers are going to become my numbers. Oops. All right. So I'm going to write the numbers 6, negative 19, positive 16, negative 4. So here's what I do. I drop this down, and it becomes 6. Now multiply. So drop, multiply. 2 times 6 is 12. Add. Negative 19 and 12 is negative 7. Multiply. 2 times negative 7 is negative 14. Add. 16 plus negative 14 is 2. Multiply. 2 times 2 is 4. And then I add, and that is going to be negative 4 plus 4 is 0. So my remainder is 0. These numbers are my answers. I did this in blue before. I was just checking what color. These numbers, these are my answers right here. So I'm just going to have to throw in the x's, but it's always one lower power than what I had. So it's going to be 6x squared minus 7x plus 2. The original problem was 6x cubed, right? So see how when I add those x's back in, I'm starting at one power lower than what I had. All right, let's try one more. So this number right here, all right, that's going to be here. And that number has to have the opposite sign, so it's going to be negative 5. I'm going to take all these exponents. So there is a 1, that's x to the 4th. I'm missing an x to the 3rd, so I need a 0. Then negative 10 for the x squared, negative 2 for the x, and 4 for that. All right, so you drop the number down, multiply, negative 5 times 1 is negative 5, add, 0 plus negative 5 is negative 5, multiply, negative 5 times negative 5 is positive 25, add, negative 10 plus 25 is 15, multiply, negative 5 times 15 is negative 75, add, negative 77, multiply, negative 5 times negative 77 is negative 385, and add 4 plus negative 385 is 389. My last number right here is my remainder, so that's my remainder. These numbers are the coefficients. Now my original problem was x to the 4th, so this is going to be 1x to the 3rd minus 5x squared plus 15x minus 77, and here's my remainder, 389 over my original x plus 5, and that's my answer. Again, you can only use the synthetic division if that original, the thing that you're dividing by, the divisor is x minus a. It only works with that. All right, so we'll try both the regular division and the synthetic division tomorrow.